Let's find the square of a sum of two numbers, say a and b. Squaring means multiplying a number by itself. Using the distributive property, we can distribute a to each of the terms in the second expression, getting a squared plus ab. Then distributing b to each term, we get ab, writing the product in alphabetical order, by the way, plus b squared. Combining the two like terms in the middle, we get 2ab. Bringing down the rest of the terms, we have a trinomial, which means it contains three terms. In fact, this trinomial is called the perfect square trinomial because it is the result of squaring a sum of two numbers, or binomial. When we square a binomial containing a difference of two numbers, we get a similar trinomial, except that the middle term is negative. Notice that b squared remains positive because the square of any number is positive. Using these perfect square trinomials can save you time when expanding expressions once you become familiar with the process. Let's use the perfect square trinomial to find the square of this binomial. Remember that squaring the sum of a and b results in a squared plus 2ab plus b squared. In this problem, a is 3x and b is 5. Square 3x and multiply 2, 3x, and 5 and add 5 squared. Simplifying, we get 9x squared plus 30x plus 25, which is in its simplest form. Let's use the perfect square trinomial again to find the square of this binomial, which contains a difference. Remember, squaring the difference of a and b results in a squared minus 2ab plus b squared. In this problem, a is 2x and b is y squared. Square 2x and multiply negative 2, 2x, and y squared, and add y squared squared. Simplifying using the rules of exponents, we get 4x squared minus 4xy squared plus y to the fourth. Another special case is multiplying two binomials containing the same terms, where one is a sum and the other is a difference. Let's expand it using the distributive property. First, a times a gives us a squared, and a times negative b gives us negative ab. Then b times a gives us positive ab. And finally, b times negative b is negative b squared. Notice that the two middle terms are opposites and cancel each other out, leaving us with a squared minus b squared. When you multiply the sum and the difference of two terms, the resulting expression is called the difference of two squares. In this example, we are multiplying two binomials containing the same terms where one is a sum and the other is a difference. We can apply the rules for a plus b times a minus b, where in this case a is x and b is 9. Finding the difference of two squares, we get x squared minus 9 squared, which equals x squared minus 81. This process saves a lot of time compared to expanding directly using the distributive property.